hello, welcome back to Homeschool. This is your class 10 mathematics. This is a continuation series of most expected questions in mathematics. Today we are going to discuss very important theorems from triangles chapter. One by one we are going to discuss. Theorems have its own importance. Each and every theorem is important. In your annual examination, 4 marks or 5 marks is compulsory from this chapter. And you have one more chapter circles. In that 2 theorems will be there. One theorem is compulsory for 3 marks. But from this chapter, either they may give for 5 marks or 4 marks. 4 marks plus another theorem statement for 1 mark they may ask you. So total you fix for 5 marks if you know 4 theorems. So in this session, we are going to know about basic proportionality theorem. Listen the theorem carefully and immediately you write on a paper without saying. I am sure you will be perfect with these theorems and easily you can score marks. Okay, let's begin. Basic proportionality theorem is also well known as Thales theorem. So, for writing a theorem, 5 steps are very important. What are the 5 steps? First one is statement, second one given data, third one to prove, fourth one construction, and fifth one is proof. Every step contains marks. So, be careful whenever you are writing theorem. These 5 steps are very important. So, let me start with the first step, that is statement. Statement you can write or just basic proportionality theorem heading also you can continue the statement. What is the statement? If a line is drawn parallel to one side of a triangle, to intersect other 2 sides in distinct points, comma, the other 2 sides are divided in the same ratio. Okay. So, to understand this theorem, let me draw a triangle ABC. Let me draw a line that is DE. Now, read the statement by observing the triangle. If a line is drawn parallel to one side of a triangle. What is the line here? D is a line. D is drawn parallel to which side of a triangle? BC. If a line is drawn parallel to one side of a triangle to intersect other 2 sides. What does this line do? This line intersect other 2 sides at 2 distinct points. Okay, the other 2 sides are divided in the same ratio. So once again, if a line is drawn parallel to one side of a triangle intersecting other 2 sides in distinct points, the other 2 sides are divided in the same ratio. Ratio, what is the ratio? AD by DB is equal to AE by EC. So in this way, if you learn the statement, it will be very easy. So say along with me, if a line is drawn parallel to one side of a triangle intersecting other two sides in distinct points, the other two sides are divided in the same ratio. Okay, this is about your statement. Now your second step, data. What is given in this statement? You need to write in data. What is given here? In triangle ABC, they have given DE is a line parallel to BC. So write that only, DE parallel to BC. Next, to prove. What we are going to prove? The other two sides are divided in the same ratio. What is that ratio? AD by DB is equal to AE by EC. Next, construction. We need to do little construction. What is that? Join BE, join DC and do a perpendicular on line AC. From D point, draw a perpendicular to AC. Let me mark this letter M, and from E point, do a perpendicular for AB line. That only you write here. Join DC and BE, okay, comma, and do the perpendiculars. What is that? DM, draw DM perpendicular to AC and EN perpendicular to AB. Okay, up to here, let us say again, if a line is drawn parallel to one side of a triangle, intersecting other two sides in distinct points, the other two sides are divided in the same ratio. So in data, given ABC is a triangle, DE is a line parallel to BC. So right here, in triangle ABC, DE parallel to BC. To prove the ratios are in equal. So what are the ratios? AD by DB is equal to AE by EC. Construction. Join BE, join CD, draw DM perpendicular to AC, EN perpendicular to AB. Okay, we start the proof by considering in two parts we are going to prove this theorem. How? Observe here children carefully. Top triangle, can you see here? ADE and BDE. Observe here. Top ADE and another triangle. Can you see in that figure this one? BDE. The two triangles. First case, you consider these two triangles, and in the next case, consider this triangle and EDC triangle. Okay, first let me do half of the proof. In triangle ADE and triangle BDE. If you want to improve, you can write here statement, you can write, and here reasons you need to write here. Okay. Now, in triangle ADE and BDE, I remember area of a triangle formula. I'll find area for this. Area of triangle ADE is equal to area of this triangle. So, look this triangle from this side. Okay. Consider AD as a base. Half into, what is area of a triangle formula? We know area of a triangle is equal to half into base into height. Half into base. Let me consider AD and height. On this line, what height you can see? EN, right? So this one you write here. EN. Okay. Next, consider another triangle. Area of triangle BDE, that is equal to half into this triangle also. From this side you consider as a base. Half into DB into Can you see any perpendicular on DB? But in that figure, on AB, there is a perpendicular, that is EN. Write that only as a height. Okay, in your third step, divide these two children, area of triangle ADE by area of triangle BDE is equal to half, same lines you repeat here, AD into EN by half into DB into EN. EN cancel, half of cancel, you are left with AD by DB. You are left with area of triangle ADE by area of triangle BDE is equal to AD by DB. Mark it first equation. Okay. So now next. Again I'll take ADE triangle and EDC triangle. Observe carefully. ADE, EDC. So write here in triangle ADE and triangle DEC. Same manner, how you have done that? Same manner. Area of triangle ADE is equal to half into. Now same triangle I have taken there, but I have taken their base AD. But now I'll compare the triangle from this side. Okay. Now base, what I am going to take? AE into. On this line, what is the perpendicular you can see? DM. Again in reason, same manner you can write area of a triangle is equal to half into base into height. Same you repeat the reason here. Then again another triangle, area of triangle DEC is equal to half into. What is the base for this triangle? Observe from this side. EC into. On this triangle I cannot see any height, but overall on AC line I can see a perpendicular, so that only you consider it as a height into DM. Then divide these two, area of triangle ADE by, again same two lines we are repeating. Okay, we are not writing any new line. Area of triangle DEC is equal to half into AE into DM by half into EC into DM. DM cancel, half cancel. AE by EC. So rewrite here AE by EC and mark it second equation. Same area reason you can write here also. So now on comparing these two equations, what I can say? Here area of triangle ADE, area of triangle BDE. Area of triangle ADE, area of triangle DEC. So these two triangles, observe BDE, DEC. BDE, DEC. The two triangles lying on a same base. So I can equate those two triangles. Therefore, what I can say here? Therefore, AD by DB is equal to AE by EC. What is the reason you are going to write here? Therefore, area of triangle BDE is equal to area of triangle DEC. The two triangles are lying on the same base. So, the area is equal. Therefore, we can directly equate AD by DB is equal to AE by EC. And end up with the last line, hence it is proved. That's it. This is very simple basic proportionality theorem. And when you want to remember in shortcut, just you remember these two lines and these two lines. If you remember these two lines, divide, cancel, you are going to get the ratio. So let's have a quick recap of this theorem. This is basic proportionality theorem or Thales theorem statement. If a line is drawn parallel to one side of a triangle intersecting other two sides in distinct points, the other two sides are divided in the same ratio, right? So data given ABC is a triangle and DE is parallel to BC. To prove AD by DB is equal to AE by EC. Construction: join BE, join CD and draw DM perpendicular to AC, EN perpendicular to AB. Proof: in triangle ADE and triangle BDE. Triangle ADE, area of a triangle formula, half into base AD into height EN. Here for this triangle, half into base DB into height EN. So EN and half will be cancelled. You are left with AD by DB. Mark it first equation. Now again consider the same top small triangle and this side triangle. Area of this triangle, half into base AE into height DM. And this triangle, half into base EE and height DM. Okay, and height DM. So there also half and DM will be cancelled. You are left with AE by EC. So on comparing the two equations, on comparing both the equations, what you can say? Area of triangle ADE, area of triangle ADE is same, and area of triangle BDE, triangle DEC. The two triangles area also same because the two triangles are lying on the same base. You can write that, or both the areas are equal. You can write therefore what you can do? You can equate both the ratios, that is AD by DB is equal to AE by EC. Okay, hence it is proved. Now if you are perfect, you can start writing the theorem. If you need still practice, listen one more time the video and then write the theorem without saying. Right? We are going to meet in our next session with another theorem. Until then, keep watching. Thank you all.